right, welcome to the Embedded App of the Day. What I do every so often is I show different types of embedded systems that are available or that you might encounter in real life. And this is an interesting one in that, let's see if you can even understand or guess what this is. Have any guess? Oh, fire alarm. Smoke detector. So it is a controller for a ceiling fan. And so if you look at most ceiling fans, you know, it has those little pull cords, right? Well, this is designed for those where you don't have the ability to have those pull cords and might be too far away, or you just want to have a remote control and just click it on. So I've started to do some pulling apart of this, so I'll just show you this. This is the case for it, and by the way, this broke on my ceiling fan, and I bought a replacement of this part only for $50. The ceiling fan is like $240, so you know, to fix it, I could either replace the whole thing for $240 or just replace this part. This actually goes to the light, and this hooks up to some of the wiring that's done in the fan itself. So this whole device here just plops into it's a large area on a ceiling fan. I should have had a picture, but you know, take off the cover. Take the electronic boards out, and it's left with this device. Notice that, wow, this is a big old piece of metal, and this big old piece of metal is connected to a transistor. So it's used as a heat sink to cool that down. It has some boards, a board on the bottom and a board on the top. Now, what you see mostly here, these are very, very large capacitors. We have two relays, some other capacitors, some other chips. This is another transistor. You know, I'm looking at this, and it looks as if my failure might be associated with this area of the circuit that looks like it's crispy and burned. So I'm figuring that's what it is. But I didn't want to have to go about debugging it. So this is a device that will have a lot of analog aspects to it. So yeah, I'm really interested in just the digital part. You would think that this might be the digital part here. And again, since I don't have a schematic for this, I'm not quite sure where everything is. But this is an amplifier, so that doesn't look like it could be it. So it turns out that these can be separated. And since we have some wires going between the upper board and the lower board, that kind of leads me to believe that these might be control wires. And since these are obviously very analog components, it leads me to believe that this could be the board that's used for digital. And so looking around, this board only had like 4 points on it that came off, so that doesn't really look quite at look like a controllable area. Oh, but here's another control type of concept right here. There's a bunch of jumper wires, and these are jumpers. And these jumpers are actually used to configure an address. So I'm getting closer to some digital area. And so I turn the board over, and by the way, there's of course some wires. This is insulation between. And it turns out that there's my microprocessor. And how do I know that that's my microprocessor? Well, one thing that we often see is that this is the input from those little wires for setting. And often what they do in consumer electronics is they put the microprocessor die on the board itself, they connect with some of the wires, and then they put this big old glob of epoxy on it. And that saves the manufacturer from having to actually solder a microcontroller, especially if it's a simple one, like maybe a simple 4-bit or 8-bit with only a couple of I/O wires coming off of it. And so what we have underneath here is the microcontroller. And unfortunately, since there's a big old blob of epoxy on here, I don't know what it is. But I just thought I would show you that in this case, there's some digital control, and the digital control will actually, it's got a lot of other analog components out here. In fact, one thing that lets me know, on the printed circuit board, it has the letter X1. Do you know what that means? It's a crystal. So this provides the clock for my microcontroller. So that means I would figure the microcontroller is somewhere near that clock. And as it turns out, yep, there it is, right down there. It's the microcontroller, or the clock itself. The inputs are right here, right there, going into my microcontroller. And so I just thought I would show you an example of an embedded system. So historically, you would have the little pull cord, and there's actually a lot of different electronics in the typical ceiling fan nowadays. Things like relays and switches to be able to turn on and off the power at certain voltages, and so you could have a fan that is low power or low spin, medium spin, and high spin. All right, and that was today's app of the day, a controller for a ceiling fan.